We are Masters College of Calgary, Alberta.
Most people will know somebody impacted by skin cancer in their lifetime. Although it is becoming a more common disease and technology is always progressing, diagnosing skin cancer is still an invasive procedure.
The leading cause of melanoma is UV radiation, often caused by the sun or artificial sources. Melanoma is a type of cancer that anyone can get, regardless of age, race, or gender, and is particularly prominent in areas where UV radiation from the sun is high.
Melanoma can be difficult to detect, as in its early stages it looks like a mole and it can be found anywhere on the body. It is very easy to disregard as something critical to be looked at by a professional. Harmful growths of melanoma can also go undiagnosed for longer because it can appear in less exposed areas, and people aren't generally looking for skin cancer in areas they are covering with clothing or sun protectant.
Because this cancer is so prominent in society, it is a pretty big issue, specifically in Canada. Around 10,800 people will be diagnosed with melanoma per year, and 1,250 people will die as a result of it.
Our biology teacher is among one of the people who received a skin cancer diagnosis and treatment. As treatment, she underwent Mohs procedure, which is a surgical technique where the skin is analyzed layer by layer under a microscope to ensure that the surgeon is removing all skin cancer from the region. The process repeats until the area is clear of skin cancer. The surgeon who operated on our teacher stated that she was the youngest person they had ever performed the procedure on. And the patients are only getting younger and their cases will only get more severe.
Mohs procedure is one way in which skin cancer is identified, but as discussed earlier, this is not an entirely friendly procedure, as it involves digging into the skin and removing its layers. Our goal is to create a new method of identifying skin cancer, which hopefully may decrease stigma around going and getting a diagnosis, and ultimately encourage more individuals to get tested for concerning regions of skin.
In order to solve this problem, we wanted to create a sort of patch that would be placed on areas of concern that would be able to assist in the identification of melanoma in patients. This way, people won't need their skin sliced open without knowing for sure if they have skin cancer or not.
Key principles of melanomas that make them distinct from regular skin cells are that cells rapidly divide in an uncontrolled manner, forming small tumors that impact overall surrounding tissues. Skin cancers like melanoma are specifically dangerous as they can spread through the bloodstream and lymphatic system, which extends throughout the body.
A specific mutated protein, known as BRAF, can be identified in most melanoma cells. Usually, BRAF is responsible for directing cell growth and division. If there is a mutation in this gene, the cell will cease its regulation of division and begin to divide itself uncontrollably, ultimately leading to melanoma.
Since BRAF is integrated into the molecular structure of the cell, it would not be detectable purely on the surface of the skin. However, what could be detected from the skin's surface are chemical and metabolic changes that are caused by the mutated protein. These changes could include pH changes or enzyme activity.
In our solution, users will be able to place the patch over their area of concern to detect changes in pH levels of that part of the skin. Since the regular pH of skin is around 4.7, in most cases, we will use methyl orange in our patch to indicate the change. Since methyl orange has a range from 3.3 to 4.4, it will give users a good indication of the pH of their skin. This solution is undoubtedly better than the current methods of melanoma detection because of how non-invasive it is. Often the experience is incredibly unpleasant, like our biology teacher story, and can drive people away from wanting to get the procedure done. Early detection also reduces the need for invasive surgeries and complex treatments, saving lives and healthcare resources. It is also important to take into account accessibility. This patch would be just as regulated as a pregnancy test and could be sold in convenience or grocery stores. In order to showcase our prototype, we will first begin with a drawing and explanation of the different components of our project. A specific lab we had in mind was to find a sample of mammalian skin, since many mammals experience the same kind of melanoma as humans, and put it through certain pressures that would change the pH. We would then use indicators to see if they can detect the pH from the surface of the skin. We will do this test until we get reliable results that prove what we want to do will work. If slight pH decreases are able to be detected by our indicators, then we will know that the patch placed on a questionable mole will give feedback.
The big limitation is that because the skin's outer layer is relatively dry, a barrier to diffusion, and already acidic, around 5, detecting the tumor's internal acidity may be quite difficult. However, metabolic activity and increased blood flow in the melanoma may produce localized heat differences that diffuse more efficiently into the skin surface, which could make temperature another testing point of the patch.
Once we are able to examine skin cells for pH and temperature changes, we'll know that our patch has a solid theory behind it and be able to bring this idea to life.
Thank you so much for considering our proposal.